Hello. Good day. This is Sir Lawrence of Maragol Integrated School. How are you today? This video is intended for grade 8. But before we proceed with the presentation of this video, might I ask you to find your most comfortable place? Thank you. This video is intended for the first quarter, week 3, which is scheduled on October 19 to 22, 2020. The module is entitled Illustrating Rational Algebraic Expressions. Let us define rational algebraic expression. A rational algebraic expression is an expression that can be written in the form of the ratio between P and Q, where P and Q are polynomials, and Q must not be equal to 0. In other words, a rational algebraic expression is an expression whose numerator and denominator are polynomials. Let me repeat. A rational algebraic expression is composed of a numerator and denominator. The denominator, which is q, must not be equal to 0. I repeat, the denominator, which is q, must not be equal to 0. For the expression will become undefined. Any number which is divided by 0 is undefined, as we all know. Here are some examples of rational algebraic expressions. First one, 6 all over x minus 3. Second one, y squared minus 1 all over y cubed minus 3. And 18n plus 1 all over n squared plus n minus 2. We can observe that all these three examples are in the form P over Q. The numerators are 6, y squared minus 1, and 18 plus 1, while the denominators are x minus 3, y cubed minus 3, n squared plus n minus 2, respectively. All of these expressions are rational algebraic expressions since these contain polynomial expressions in both numerator and denominator, respectively. Now, here are some examples of non-rational algebraic expressions. I have 4 examples here. First one, 2x raised to negative 2 minus 3 all over 5 square root of x. Second one, 3x minus square root of y all over x plus 6. Third one, 3x minus square root of y all over 5 square root of x. And the last one is 3 plus 1 all over 2 minus x all over z raised to negative 2 plus 5. All of these expressions are not rational algebraic expressions since the expressions contain irrational numbers which is in the form of radicals, which is the square root of x and square root of y, and variables having negative exponents such as x raised to negative 2 and z raised to negative 3, which are not polynomials, irrational numbers, and variables having negative exponents are not considered polynomials. So what can we observe in both of them, A and B? We can say they have both similarities and differences. Let us identify first the similarities. Rational algebraic expression and non-rational algebraic expression are both in the form of the ratio between P and Q. They both have the same, having a numerator and denominator. Another similarity is that they contain either a variable, a constant, or both. The only difference between the rational algebraic expression and the non-rational algebraic expression is that a non-rational algebraic expression contains irrational numbers or negative exponents. That's the only difference. So we can identify now which of these two is a non-rational algebraic expression and a rational algebraic expression. I have here a checklist in identifying whether the expression is a rational algebraic expression. First one, the expression must be in the form of a fraction. Number two, the expression must have in its numerator and denominator a constant, a variable, or a combination of both, which are polynomial expressions. And number three, the expression must not have a negative exponent, a radical sign, or a fraction exponent in the variables in both numerator and denominator. So we should remember always to check whether a rational algebraic expression has all of these three characteristics. Let us recall the definition of a rational algebraic expression. The denominator cannot be equal to 0. When that case happens, the denominator or the whole expression is now undefined, or in layman's term, that is meaningless. In rational algebraic expressions, you need to pay attention to what values of the variables that will make the denominator equal to 0. When it comes to those values, whenever you have encountered those values, they are called the excluded values. Meaning excluded, do not belong on the range. They do not belong on the domain. So therefore, they are called excluded values. Okay, let's proceed with an illustrative example 1. Identify the value of x that will make 6 all over x minus 3 undefined. I have here the solution. Step 1. Let the expression in the denominator be equal to 0. The denominator is x minus 3. Let us equate it with 0, as step 1 says. That will make us x minus 3 is equal to 0. Step 2. Solve the equation to determine the value or values of the variable. Since we have here x minus 3 is equal to 0, all we have to do is the what? Add 3 to make the expression here. Ayan, dito tayo. You have to add 3 on both sides, which is using the addition property of equality. That is negative 3 plus 3, which gives us 0. 0 plus 3, which gives us 3, therefore, which is by law for simplifying. Now, we have the final answer as 3. Now, this value now, x is equal to 3, will make now the irrational algebraic expression undefined. Let me show you. This means that when x is equal to 3, the expression 6 all over x minus 3 is undefined. Ngayon tayo. Thus, x is equal to 3 is an excluded value in the given rational algebraic expression. Or in other words, x cannot be 3. What happens if you substitute 3 to the expression? What happens? Let us see. The process is to substitute 3 to the expression. Now we have here 6 all over x minus 3, the same expression that we have earlier. So we have to substitute 3 with those x's or x. So we have 6 all over 3 minus 3, which is equal to 6 all over 0. Now, since this particular expression is actually giving us an undefined term, so therefore, it is meaningless. Since the division of any number is actually undefined, therefore, again, since the division of any number by 0 is undefined, therefore, 3 is an excluded value for this rational algebraic expression. Okay, let's proceed with an illustrative example number 2. I have here a rational algebraic expression y minus 3 all over y squared minus 16. First thing to do is to locate the denominator. The denominator is y squared minus 16. Let us factor this out. We can factor this out as y plus 4 multiplied by y minus 4. So we have here two expressions, y plus 4 and y minus 4. So we have two values for our excluded values. We have obtained that whenever we equate y plus 4 into 0, we can calculate it or simplify it as y minus 4. The other one is y minus 4. We can have the value as 4. So therefore, we have two values which is now excluded. Those are negative 4 and positive 4. It's very easy, guys. Thank you. Let's have illustrative example number 3. I have here y squared plus 5y plus 6 all over 3y squared plus 2y minus 8. First things first, we have to identify the denominator. Pretty good. Now, what do we mean by this one? 3y squared plus 2y minus 8. We can actually factor it out as 3y minus 4 and y plus 2. I have here another two expressions, 3y minus 4 and y plus 2. Now, if we're going to equate 3y minus 4 into 0 to 0, so we have 4 over 3. While the other one, y plus 2, we can equate it, we're going to equate it into 0. That will give us the value of negative 2. Okay, that's how we do it now. we have the values for the excluded ones. We have 4 thirds and we have negative 2. Now let's have another one. We have to simplify and state the excluded values. I have here 4x all over 28x squared. We can simplify 4x by expanding it into 2 multiplied by 2 multiplied by x. And 28x squared as 2 multiplied by 2 multiplied by 7 multiplied by x and multiplied by x. Or simply, we can cancel out some of the terms. We can cancel out 2 and 2 because we have here both 2 again. Another one, we can cancel out x and x. What do we have left? We are left with 1, simply 1 here, and then the 7. So we have 1 over 7x, which is what? That x should not be equal to 0. Let's have another example. Simplify and state the excluded values. The same with the previous one. I have here m squared plus m minus 20 all over m squared minus 25. We can factor out m squared plus m minus 20, and we can factor out m squared minus 25. What do we mean by that? We can have m squared plus m minus 20 as m minus 4 multiplied by m plus 5. And then the other one is m squared minus 25 by m plus 5 and m minus 5. Okay? And then we can see common factors, which is m plus 5 and m plus 5. So therefore, we can eliminate that by saying m minus 4 and m minus 5. So this is the simplified form of this one. But we should state the excluded values. Kailangan daw siya. So therefore, we should refer to the other one. We should refer to this one. M squared minus 25. So therefore, the factors are m plus 5 and m minus 5. So therefore, this one, if we're going to equate this one to m plus 5, that gives us m is equal to negative 5. If we're going to equate this particular m minus 5, we can have the value as m, which is not equal to 5. Now, the excluded values are here. Those are the two. Itong dalawa na to. Okay? The simplified form, the simplified one is this one. Okay? Now, you can verify that if the excluded value or values is substituted in the expression, it always ends up by 2 division by 0. You have to bear in mind that there are some values that will make expression defined too. How are we going to inspect it? The process is called evaluating the expression. Let me give you an example. Illustrative example 1. The task is to evaluate the expression y squared minus 1 all over y cubed minus 3 when y is 2. I have here the solution. Step 1. Replace the variable y with a given value. What is the given value again? That's right. The given value is 2. Now we're going to replace the variable now. We're going to replace the variable y, this one, with the given value, which is 2. The expression says y squared minus 1 all over y cubed minus 3, which is equal to, we're going to replace all of the y's here with 2. Now, I have here, I have already replaced y squared with 2 squared minus 1 all over y cubed, that gives us 2 cubed minus 3, which is by substitution. Now, number 2, step 2, we just have to simplify the numerator and then the denominator. It says here that 2 squared minus 1 and 2 cubed minus 3. That gives us 2 squared is 4 and 2 cubed is 8. That gives us expression 4 minus 1 and 8 minus 3. Furthermore, 4 minus 1 is what? That is 3. 8 minus 3 is 5. Now, the evaluated value, or the value now, of the expression y squared minus 1 all over y cubed minus 3 when y is 2, that is actually 3/5. Now, okay, I have here another example. Let's try to evaluate y squared plus 5y plus 6 all over 3y squared plus 2y minus 8 when y is equal to 1. First step is to substitute all the value of negative 1 to all of the y's. By doing so, we can have negative 1 squared plus 5 multiplied by negative 1 plus 6. See, we have just substituted every y on the numerator with negative 1 here. Okay. Another one, we have 3y squared plus 2y minus 8. We have just substituted y squared here. Okay. Negative 1, 3 multiplied by negative 1 squared plus 2 multiplied by negative 1 and then minus 8. Simplifying, we have negative 1 multiplied by negative 1 is 1. Here, 1. 5 multiplied by negative 1 is negative 5. And plus 6. Multiplied all over 3, which is negative 1 multiplied by negative 1, or negative 1 squared is 1 multiplied by 3, which is 3. And then 2 multiplied by negative 1 is negative 2, or minus 2, and then minus 8. Simplifying further, we have 1 minus 5 plus 6, which is 2. 3 minus 2 minus 8, which is negative 7. Or, just simply putting negative 2, or the negative sign in front, which is negative 2 over 7. We're just the same value. So whenever y is negative 1, for that particular example or rational algebraic expression, we have the value as negative 2 over 7. Okay, last example. I have illustrative example number 3. I have here 5m squared plus 6m minus 8 all over 3m squared plus 5m minus 2. We just have to use negative 2, or we're going to evaluate it using negative 2. Now, what do we have here? We have to substitute negative 2 on each m. That gives us 5 multiplied by negative 2 squared plus 6 multiplied by negative 2 minus 8 all over 3 multiplied by negative 2 squared plus 5 multiplied by negative 2 minus 2. On this particular example, we should go with the MDAS first, or PEMDAS on other books would say. We have negative 2 times negative 2, or which is negative 2 squared, which gives us 4, and then as well as this one. And we can simplify this one as well. This negative 2 and negative 2 here. 6 times negative 2 is negative 12. Sorry, negative 12. 5 times negative 2 is negative 10. That gives us 5 times 4. And then negative 12, as I have said, minus 8. And then 3 times 4, and then minus 10, minus 2. Okay. The last one is 5 times 4, that gives us 20. Minus 12, minus 8, and then 12 minus 10, minus 2. That will give us the final answer as this one first, 20 minus 12 minus 8, which is what? 0. 12 minus 10 minus 2, which is again 0. 0 over 0 is still undefined. Okay. For exercises, let us simplify and state the excluded values. I have here 2x squared plus 11x plus 9 all over x squared minus 10x minus 11. Pause the video for you to process, to simplify and state the excluded value. You should arrive at x should not be equal to 11 and x should not be equal to negative 1. Very good. Last one, we have to evaluate 7z squared plus 23z plus 6 all over z squared plus 2z minus 3, where z is equal to negative 3. Again, pause the video for you to process, to evaluate the expression. Now you should arrive at 0 over 0, which is undefined. Now that ends my presentation about the illustration of rational algebraic expression, as well as simplification and its evaluation. Thank you and God bless.